Hello Year 12 and welcome to the fifth video here for our unit on trigonometric functions. And what we want to look at in this video is the derivative of trigonometric functions, right? We want to differentiate sine, cos and tan, essentially. Now, what I'm going to ask you to do is to remember these three standard derivatives. You'll find them on your formula sheet as well. But we need to know the differential of sine is cos, differential of cos is negative sine, and the differential of tan is sec squared. Now, if you'll take my word that the differential of sine is cos, and the differential of cos is negative sine, we could define tan as sine over cos, and then use the quotient rule, and you're going to see that that sort of all works out, cancels out, and we end up with sec squared anyway. But remember these here, and I think we're going to find, given our background now with differentiating, that these are no harder than a lot of other differentials we've done before, derivatives we've done before. So, let's have a look here. The differential of sine x plus cos x. Of course, we can differentiate them separately. Yeah. So, but nonetheless, we're just going to write it like this. The differential of sine is cos. So it's cos x, and the differential of cos x is negative sine x. And that's it. Right, just like that. Certainly no more difficult than many other derivatives we've done before. Now, we can use the chain rule. Right, we've got a couple of ways of doing that. We'll work through some of those in class, but again, these are so simple that we've kind of got to complicate it a bit to keep you busy, keep you on your toes. So some chain rule, product rule, quotient rule sort of questions, right? We'll find examples of those. Now, if we apply the chain rule, then we do end up with a couple more standard derivatives. Okay, now I don't know why we sort of look at just this class here, where it's ax plus b. Right, I don't know why we look at those, but nonetheless, let's look at these ones here. So, by our standard derivative, I could say that this is going to be 2 cos 2x plus 5. But let's use the chain rule in its longest form, just because, well, you know, it's good practice. I wouldn't ask you to do this every time, but if you get a bit stuck, I find the chain rule to be a very handy tool for working carefully through fairly complicated derivatives. So I'm going to say, let u equal this thing in the brackets, because, you know, sine x, that's very straightforward. I don't have that. I kind of wish that it were. So we're going to say let u equal 2x plus 5. That will mean that my function now is sine of u, right? Which is nice, right? It's very standard. That means the differential of that. So if I differentiate y with respect to u, I get differential of sine u is cos u. And I'm just going to substitute that back in. dy on du equals the cos of 2x plus 5. Now I'm going to come over here. If I differentiate u with respect to x, I get, I just get need 2, don't I? Yeah. And I can say that dy by dx, which is what we're trying to find, that's the differential of y with respect to x, dy by dx equals, right, du by dx times dy by du. Okay, and then the sort of, the du's cancel out there as such, kind of, sort of, and I'm left with dy by dx. And it just happens that I've got du by dx, that's this one here, so that's equal to 2 times dy by du is cos 2x plus 5. Right, 2 cos 2x plus 5, just the same as this standard one suggests to us. Okay, now, because we are getting close towards the end of this video, it's pretty brief. We can, if we get something like, you know, if I can suggest to you something like, I'm just going to write here, if I say y equals the sine of some function of x, then the derivative of that is going to be the differential of my function by the cos of that function, not the differential, right? Now that's true in many cases here, but just sort of a bit of a reminder here, right? That's going to be true for cos, except we get this one here. In fact, this is how our chain rule works, right? Or a function of a function, it's sometimes described. In fact, if I just say this is the g of the f of x, the differential of that is f prime x times g prime f of x. I don't know. Sounds a lot like that. Anyhow, that is differentiating trig functions. In the scheme of things, I think that's pretty easy. Work through lots of examples there. Hopefully we can find some tricky ones. I'll see you in class.